So this is our project. This is this is where we spend most of our days. We don't live here, but this is our studio. We have workspace for 10 people, dual monitors, and it's a tiny little building at 10,097 square feet. So it's
conditioned space, yeah.
1,097 square feet. So it's little, it was.
And gross square foot, Prudence is right. It was about 1,500 square feet if we count all the thickness of the installation.
Yeah. Okay. So.
All right. Scrolling page down. So this is as a front entry, and this is what we bought.
We bought what we could afford, which is this sad little structure on Main Street in a historic district. So we're in the Hudson Valley of New York, and it's a beautiful little town. It's 1 square mile. It's about 2,000 people, but we're an hour and 10 minutes from north of New York City on the train line, and pretty much the entire village is a National Historic District. So.
And our next door neighbor is gas station, and I didn't want to buy next door to gas station, but James convinced me that in 10 years that it won't be. So, and so maybe you can just run through a quick proposal that we made because it's an historic district.
Yeah. So as in the historic district, we had some pushback that to do a deep energy retrofit to the building envelope. We had part of the board, the historic review board, who was pushing to keep the building as it was, even the split old rotten siding. But we knew there were people on the board who recognized that this is their best shot at saving this building because anybody else would have torn that little thing down. So
the certain points to make here, they of course wanted us to preserve the stone walls and the siding, novelty siding. So we negotiated on replacing it with new, but same profile. They had no purview on color, so we got away with that. They weren't too thrilled about the deep windows, window wells, or the big giant overhang of the insulated top volume. We mitigated that as best as we could. We proposed to lift the building off the ground. So if we, you see the original building was sinking to the ground. So we proposed to raise it for multiple reasons. One is to thermally break, to give a higher ceiling in the basement, and to get it out of the termite zone. So, and we also negotiated on the door and window heights, so on and so forth. And the light well, you want to talk about the light well?
Yeah, so we added that light well to bring in, to give us big high ceiling windows into this space, so it can really bring in natural daylight. And here's it's the only historic image that we could actually get of this house, strangely, but or this building. But here it is in the context of probably 1930, maybe 1920, there's you can see the outline of our building here. But this was once actually a lace factory, and now that's been torn down for the gas station and now a much wider roadway. And so the strategy that we had was to kind of classic follow the lines around, making the exterior sheathing layer of the existing building, the air tightness layer, over insulating for that. And then in the basement, we'd flip that. The original goal was to retain the original stone walls and then insulate to the inside. So a simple plan. Here's the concept that I sketched up just one night when I couldn't sleep. And so the simple idea was to leave the existing stone walls, lift the building up, and extend the stonework up with a thermal break and foam glass so that we can make continuity for thermal and air sealing.
And in the back of my mind, I'm always wondering, how is that new and old stone wall going to look, one against another?
And so here you see the original framing. We chose to expose it for the roof, and the skip sheathing from the old wood cedar shingles that were on it. Miraculously, this horseshoe shop did not burn down. It just had big open a big open hearth in the center and had a forge in the center, and then had 2 roof vents, which we actually replaced with light tubes. And so the original sketch is here, you know, just trimming off the rafter tails and putting new wall sheathing here, and then wrapping the whole thing with an air tightness layer. Then recreating to the outside those rafter tails and just kind of giving it a puffed up look. And we came up with a pretty good, this is a window section in the basement plan detail, where we introduced foam glass actually around the perimeter like that, so that we were able to get over insulation on the frame, and then just did a little stucco wash there to make it blend into the stonework. And so here it is, you know, just extending up the stonework, nice and easy. Same idea with the foam glass wrapping all the way around. But then we realized that the stone foundations had to go. So we stuck with the same plan, but then moved the framing out, so because the goal was to support the original structure. So we moved the plane of the masonry out so that we're bringing the stonework out, so that it reduced the amount of overhang there. And we reclad we created a shelf in the masonry to reclad with reclaimed stone from the original foundation, which is the glacial till, you know, throughout the Hudson Valley here. And so solar, you know, the typical energy loads for an office, and, you know, even with PV, we weren't able to meet our primary energy demands. And, you know, it has a lot to do with the small building penalty, which if we added just 300 square feet of, you know, of loft space, we would have actually been hit passing. So I'm going to just kind of cruise past these. We found that that the heating loads and the cooling loads are actually not very accurate as modeled. We have no problem heating the building. We do require more cooling than the model suggests. And if we were to shift the building, you know, you can see here, if we just added a little bit of square footage, we would be passing. And so this is just a kind of a study of various projects that we've done, you know, floor area ratios. And then back to the energy modeling, once we added a preconditioning loop in the Comfofon for the Zender, we actually brought it into passing. So we just basically have ground temperature water in contact with the soil under the insulation of the basement floor, and that gives us all the kind of tempering that we need to make our primary energy pass. And so then the work begins. Here we are tearing off this little shed addition off the back, which we end up recreating to create the stairwell. As we did that demo, we realized that the rubble foundation was just really bad to begin with, but just really eroded. There's no mortar left. And as we dug further, we discovered gasoline from the gas station. So we had subsoil contamination. So we braced the building. Originally, we had a moving company lift the building. So then since it was already up in the air, we decided to have them basically skid it into the backyard there. And there's our fantastic foundation. And we had that tank, we removed that. But once we removed all this rubble, we were able to gain back quite a lot of space actually on the interior.
And taking a pause, we were saying, you know, the bright side of the thing is that good thing that we were doing, we were already committed to extensive renovation. I said, can you imagine, you know, we were just laymen and just bought into the office and we renovated the heck out of the interior and moved in. What would have, you know, what we had then, you know, discovering afterwards and moving out again, you know, so we were saying, thank God we found out, you know, before.
Yeah, well, and then particularly about the soil contamination from the gasoline. It was a full dump truck of gasoline contaminated soil from an old leak. So that would have been our interior space that we, you know, if people were just doing a good enough building, they would have been, you know, actually capturing more of that fumes inside. So, so here we are with the foundations now recreated, and the building being skidded back in. You can see our foam glass and then our vapor barrier kind of flopped over. But the simple plan of just setting the building back down is made much more complex by this system of steel I-beams that we need to pull out the needle beams. So we had to kind of repair, but we did pretty well. So we used reclaimed EPS foam insulation for the basement, and we used actually the final layer of that buildup to the inside of the vapor barrier to protect the vapor barrier from all the work and the sharp edges of the welded wire. And so that's some leftovers from it, but you can see our vapor barrier just waiting to be extended up and then sealed to what's flopped up there above the foam glass. So you can see that the foam glass marching all the way around there. And that's our source for green insulation. You can come back to that. And so at the end, we basically came back with a timber frame that we reclad. And so we reskinned the walls. We used the same plywood that was overlaid on top of the original skip sheathing, and then wrapped it with this 3M peel and stick film, which was really great.
Friends have said that we should have built a couple of bleachers across the street so that the neighbors can sit there and watch us, because it was so entertaining for the neighbors.
So then we built up, we have 14-inch Larson trusses on the walls. We made a decision to expose the timber frame on the inside. So what was originally 10-inch Larson trusses, we then boosted up to 14 inches so that we can get all that extra R value outside and meet our energy model. We have 16-inch Larson trusses across the roof. And then you can see here where we've recreated in hemlock, which is the original species, the rafter extensions. And so this is our air test, our air tightness testing results. We did actually phenomenally well. So 0.24, actually in the final average ACH 50 at 0.2. So we far exceeded what we were supposed to hit. CFM 50 for the shell, 0.0138. So really, a very, very tight building.
Yeah.
It's about the equivalent of half of a credit card in surface area. And so, people are like, you're crazy for all that you've done. But when we sat back and looked at the space that we've created for ourselves, we realized we weren't so crazy. It might have been a labor of love, but we have marmoleum floors, true linoleum floors upstairs. And the guys who were installing it was a bitter cold day, and gave Juhee very strict instructions to.
Right, and when he came, well, before he came, he said, I need real heat. I need my material to acclimate to the temperature. And he came and I gave him a tiny little space heater to plug in. He got so mad
tiny
at
little
me.
quartz ones this big.
And he was so mad. He said, I told you I need real heat. And then about noon, he had to unplug and he had to open the doors.
He was all sweaty.
And he said, I've never seen anything like this.
And so this is what us moved in. We kind of always have party lights because we haven't been, we just haven't gone on to actually buy the final lights. But it's a really great space, and we use it for everything. And so this is the new addition, that little shed addition that we tore off. We put our stairwell and our mechanical system. There's this ledge that was created, in the transition at the foundation that we took advantage and made into a shelf, as well as our whole mechanical system.
So this is our entire mechanical system, and then there's a tiny on-demand hot water heater downstairs in our kitchen broom closet, which we hardly use.
Yeah, we turned it off mostly. So here's a solar tube, and the amount of light that it throws down is just incredible. But then, so this is our system on display. So a tiny little 9,000 kBtu heat pump, and then our Comfo font here and our Zender 350. And we use the larger Zender. We could have gone smaller, but Comfo font is only adaptable to the 350 or the 550.
And that's only one unit that we use for both floors.
So, and then, here's the reclaimed barn door that was on the side of the building. I welded that up the very first day of the COVID shutdown, actually, and cut the top of my finger off, actually, doing it. And a reclaimed historic window from a local project that, I shut, if we have two different conversations, we can kind of shut it down and control noise. And some, some kind of our outfit there. And we, downstairs is decidedly more modern and clean. Open tread stairs that really bring that natural light down. You can see that, and it's dog friendly. And so just kind of what's out there. There's some decent federal and state incentives.
We were able to pursue a couple of them. Of course, the solar panel incentives was the easy one. The SBA loan for MWBE businesses, that's what we had pursued. And the paperwork for that was so overwhelming that we couldn't pursue any other incentives. So after the fact, we learned that there's actually a technical preservation services incentives, tax incentives for restoring historic buildings. We didn't get to capture that, but
yeah, we were running blind.
Yeah, but yeah. So, and lessons learned. You want to go for?
Yeah, well, it was just never assume. We learned so many things on the fly, and we had to be flexible. I mean, of course, any project has just a dizzying amount of variability, but this was just an insane thing to think, okay, well, what more could we find after the gasoline? Dug up another tank in the backyard. Ended up just being a cistern, but it's just everything comes at you and then more.
And one of frustrating moment was when we had one of our guys draw the window details, and he was in the field and didn't follow his own detail. That was very frustrating. And yes, so small building penalty, that we had to deal with that. And as James had mentioned, it's easy to draw blue and red lines on paper, but it was definitely hard to execute in the field. In this case, we had used HRV to pass the Woofy passive, but we realized that it's really not ideal for our climate zone. We really should have installed ERV instead of HRV. And we were definitely thrown off by the cooling and heating and cooling loads in the Woofy model. In real life, we felt that it was reverse. And the external shades.
And probably one thing is, we do a lot on calculations on usage patterns, and the fact is that you make such a good building that your usage patterns are completely different because you spend so much more time in the space because you love it. We have parties here.
And
so you're all welcome.
And this is not lessons learned, but a couple of things that we've added to our practice to top it off is that we have organic gardens in our backyard. Right. Our contractor friend, who also has a farm, helped us get some organic soil. Yeah. We also participated in Green Business Partnership, where they make you go through the hoopla to buy green office products, to have all kinds of green measures. I can't think of it all off the top of my head. We also bought electric car recently.
So our studio is certified Source Net Zero, and still maintaining that even with the car that we're charging. So it's really great to walk